talk about
I know. What are you doing, dog? Okay. Anyway. Conversation. Why are you fighting? Like that TikTok, I was gonna see like 2 seconds.
okay, so what we're gonna do, guys, all right. So what we're gonna do is we're gonna talk about the f of x. Now, why do I capitalize this? There's a reason why I capitalize this, because if I take a d to the dx of x cubed, that's equal to 3x squared.
I was assuming that.
So what is the integration of 3x squared? X cubed, good. So it's the x cubed, right? X cubed. But there is something else more. It's not just x cubed. Why is this not x to the cube? Yes. It could be constant. Think about what if you have x cubed. Think about if I take a derivative x cubed plus 10, x cubed plus 20, x cubed plus 30. What is that result? D to the dx of x cubed plus 10, that's equal to 3x squared, right? D to the dx of x cubed plus 20 is still 3x squared. It doesn't matter if I plus 30 or 20 or 25 or 21, they'll have something, right? So there is a plus c, that c is some type of constant. The constant is going to be very, very valuable. And this is called general solutions. It's called general solutions. Once you find the c, how do you find c? So we're not going to talk about it today, but once you find c with initial conditions, and we're going to talk about later, it's called a particular solutions. Particular solutions. It's going to call particular solutions. Why that plus c is important? Because plus c, it's going to affect x cubed plus 10, x cubed plus 20, x cubed plus 30, x cubed plus 100. Doesn't matter. So when you integrate something, you need to have a plus c. If you don't have it, you will get your points off. It's not because I'm being a pain in the butt. It's because it's very, very important. Also, later on, you had to find the value of c by using initial conditions. And then that's going to call particular solution rather than general solutions.
Can you maximize the scale?
Yes, of course. Can you guys, I'm sorry, can you guys see?
Was c with the initial condition going to equal particular solution, or is it equaling, or is it creating? What did you say?
Once you find a c with the initial condition, then you can find something called particular solution. So for example, if I find out x cubed is plus 10, that's going to be a particular solution. Is that okay? Okay, so that's fairly easy. So what is the definition of antiderivative? So we're going to also talk about, d to the dx is equal to, or dy dx is equal to what? Slope, right? What else? One major word is a slope. Another major word is what? Rate of change. Good. Rate of change, there's two different kinds. What are they?
Instantaneous and accurate?
Yep, instantaneous. instantaneous. Not me.
Not it.
Average rate of change. I don't know if I spelled it right, but whatever. Is INSTANTA. I don't know. I don't know how to spell it.
I don't know if my muscle memory is right.
Okay, somebody know how to spell? Can you please tell me?
Instant, so INSTANT.
And I think it's
A-N-E. Yeah.
Oh my god, that's literally what I wrote.
Okay. I
Oh,
think
I think
I
it's
think having
interesting,
it,
but like I think it's right.
yeah.
Instantaneous. Imagine
Yeah,
Mr. Ye spelling bee contest.
Oh my god, Dad, we spelled it right.
Close.
I just looked it up. Your phone? No. What? Your phone. No, guys, that was math. Right.
It is math related. It's math related. Leave it alone. It is math related. All right. So the integration notations look like this, and later we're gonna learn is actually area under the curve, and we're gonna talk about that a couple days later between A and B. So we're gonna talk about that later. We're not gonna talk about it right now. We're gonna talk about it later.
Is that B and C or no A and B?
A and B.
Baby, I'm
Also, there's two different names. There's integration, and there is antiderivative. Okay, so there are two different names.
To make it different.
Nope.
Area under the
Does
tree.
that make it different?
No, they are interchangeable.
I'm San Francisco when use antiderivative.
Yeah. I want to scare the Greek calculators so when they use integrals.
Okay, so let's talk about definition of integral. Now this one's not gonna test it. Antiderivative. Sorry, antiderivative. So let's talk about certain things. So we're gonna say a functions f is the antiderivative of non-capital F. Non-capital F. So you gotta think about layer. The highest layer is going to be capital F. Then it's a non-capital F, which is derivative of that.
Huh?
Are you okay?
That was just a little silly answer. Yeah.
Me?
Yeah.
Why?
Can you just say that again? All of it.
A function of capital F is antiderivative of a non-capital F.
Oh.
That's so cool.
Oh, okay, that's crazy.
I'm waiting for
It took me a
Okay.
Like the capital F notation is just the antiderivative.
Yeah.
Oh, like
I literally was like, yeah.
Like what?
like F prime is.
Yeah, it's sort of.
Yeah.
Like that, yeah.
So if I take a derivative of capital F, it's going to be a non-capital F for all x. Okay, stop sounding like nerd.
It,
Calculus AB and BC. So like, I don't think you have the right to call me a nerd. Damn.
I teach it doesn't mean I talk like the nerd.
me personally, I'm not accepting.
I'm just kidding.
Yeah, I would fall for that.
I know, right?
If you want to compare grades and stuff,
I didn't there.
Oh,
She pulled it every time.
What did she say?
You want to compare grades?
Oh, wow.
Oh, I can't even tell this, right?
Who is? Let me lower Deborah's grade a little bit.
you just know Deborah's points to Jorge now.
Yeah, I think
Now you're pushing
that's pretty legit.
Yeah, I think that's pretty legit too. See, with 3 like a nerd. What nerd uses the word legit?
What nerd uses to compare grades as an attack?
Wow, bro.
Crazy.
Okay, so usually I will say, hey, can you find general solutions? And can you find general solutions, which is find out what y is of the differential equation? What does that mean? Differential equation. Differential equation is the derivative, which is y prime is equal to 2. So that means, can you find y? So what do you have to do? Yes, it's just 2x. Good. Because the integrate of 2 dx is equal to 2x, but more than that. Plus c. Thank you. So there was a plus c. So this is called a general solution again. Now, you guys already taken some integrations that you basically knew. So for example, 2 is going to become 2x, right?
Also, I have a question.
Sure.
Wait, can you swap for a second?
Do we always have to put the dx in the like?
Yes.
Okay.
dx, we're going to talk about the importance later. So thank you for mentioning that. dx is also very important. Because that's going to, later on, we're going to talk about is a partition of rectangles. And that's how wide each partition is. But then, yeah, right now you give me that face. What the hell I'm saying? But it's okay. It's you're supposed to give me that face.
Also, you want.
So not only dx is important, plus c is very important. So two things are very important that you cannot miss, because dx also later on can use for u substitutions. So you have to pay attention to that, especially what we're gonna do in Calc 2 today is gonna be, converting dx, d data to du, and all those things that you have to be very, very important. That dx is very, very valuable. But that's Calc 2's problem, not your problem. But it's also going to be your problem later. So y is equal to integration of f of x dx. And that's because f of x plus c. Okay, so this part is called integrand. This is the part is variable of integration. And this is the antiderivative of f of x. And c is called the constant of integration. Now, constant integration is very, very crucial. We're going to talk about that. That c, you don't need to have plus 2c. If you have two c's together, it's going to become 1c. So it doesn't matter how many c. If c could multiply by 10, it's still going to be c. The c is not going to change when we talk about different things. Okay, so now let's talk about basic integral rules. What do you think of integration of f? This is a fundamental theorem in calculus, but f of x dx.
It's a derivative? Which one?
The capital of x.
Antiderivative.
Okay, what's the integration of f prime, capital F prime of x dx? It's just f of x plus c. Does that make sense? Now, this part is going to be fundamental theorem of calculus part 2. This one we're going to talk about later, but since in the textbook, I kind of don't want to ruin the textbook's order. So we're going to talk about it now. We'll kind of give you a introduction of this. If I take a derivative of the integral, that's going to give you back the same functions.
Yes. Oh my god. And at the end when Brianna started singing, oh my god.
Okay, we can talk about live data we're done. I kind of want to see it too. So don't talk about it. Okay, so let's talk about basic integration. If I take a derivative of the constant, what am I going to get? 0. Okay, so if I integrate of the constant, so 0 dx is equal to c. Does that make sense? If I integrate nothing, it's going to have some type of c. If I integrate 0. If I take a derivative of the kx is equal to what? K. Does that make sense? What's the integration of k dx? Kx plus c. Good. Does that make sense? If I take an derivative of kf of x is equal to kf prime of x. Now integration of k of fx dx, that just means k can be outside of fx dx. That's called constant multiple rule. We did this before. D to the dx of f of x plus minus g of x is going to be f prime of x plus minus g prime of x. What's the integration of f of x plus g of x dx? Well, that's just going to be split up the f of x dx plus integration of g of x dx. That's just basic things. No, just splitting is like distributions. It's like you can distribute to the integral, but it's not really called in distribution. It's called sum and difference rules. If I take a derivative of 2x plus 1, what am I going to get? 2 plus 0.
There's not a single number in there. Getting me worried.
It's okay. It's now this one's really, really important. It's called power rule. So d to the dx of x to the n, or what's derivative of x to the n? Right, subtract 1, right? Now here's the thing. Can you guys think about reverse? What's integration x to the n dx? Good. All right, let's start with the plus c. Good. We'll be here. What will be the derivative?
Is it
No.
something?
Why is it not in x?
I don't know. What does that mean?
Okay, no. Let's give you an example. Let's say, hey, let's talk about example. Integration of x to the 2 dx. What is that going to be?
Oh, 2x. No. It's something square, right? No, I'm tired. Yeah, where are we going?
1/3.
Which thing derivative will give you x squared?
1/3 x
Something
cubed.
cute.
Thank you. It's 1/3 x cubed plus c. Now, do you see this 2 is going to add 1, and this denominator is going to add 1 too. So it'll be x to the m plus 1 over m plus 1.
Someone educate me.
Wait. Sorry. I have a question.
Okay, so pay attention. Let's take a derivative of this. What will happen if this gonna be going down here, right? So it'll be m plus 1 over m plus 1. Does that make sense? that is equal to x to the n plus 1 minus 1. If I take a derivative, that n plus 1 is going to move into the front. And that n plus 1 would be simplified. And this 1 plus 1 minus 1 is going to be x to the n. So that is where they come from. It's the reverse of power rule. Reverse of power rule. Okay, we're gonna finish this part up later because we got another part. We're gonna come back. It's not that hard.
Do I leave a space?
Yeah, leave some space here.
How many spaces? Like, is this good enough? Should I just start a new page?
Yeah.
Okay. And wait, what was this section of notes called?
Antiderivative and indefinite integral. Okay, so let's do integration of, I don't know.
He's never leave space, so leave some space.
Yeah, leave some space here because I'm gonna come back because of this trig integral as well. So just integration of 3x dx. We know that 3 can be outside. Is that okay?
Yeah.
And then using the power rule says 3 x to the 1 plus 1 over 1 plus 1 plus c. Why? Because this is 1. So it'd be 1 plus 1 over 1 plus 1. So it'd be 3 to the x2 over x over square. Think about it. If I take a derivative of x squared over 2, what will happen? Hey, where you been? Oh, what are you testing? Okay, what happens if you take a derivative of x squared? The 2 is going to go down, right? And 2 is going to cancel. Does that make sense? And that's going to give you 3x. That's it. Not hard.
Yeah. It's so easy.
It's easy.
Yeah.
The problem is in your mind.
I don't understand the setup that you're doing.
Because working backwards so quick, it hurts my brain.
This is x to the 1. Look,
Okay.
the power is going to add 1 divided by 1 plus 1. Why is that?
Why are we defining?
Okay, so think about it. If I take a derivative of this, what happened? The 2 is going to be in the front, subtract 1, the 2 is going to cancel.
So when you're doing that, you divide it by
Divided by the power, yes. Yes.
Oh, why are we doing that?
Why are we dividing it all?
Trying to like find a way to cancel out. Go back to cancel the top and bottom. Go back.
Oh wait, so I brought the metaphorical the power 1 down, and then but why am I adding? Should I be subtracting?
Okay, let's try this one.
What? So nice.
Hey, less, dog. Well, you can't think out of context. This is so hard to define.
If you want to double check your antiderivative is right, you can always take a derivative of your antiderivative. If you go back to original, then that's correct. But it's not that bad. Is you just look, a 7th grader can do this. You guys can do it.
My son didn't know how to do it. Seventh grade me.
What do you do?
Dude, don't even look at me, okay? Don't make eye contact.
I will tell you my experience of the world. I used to do fencing competition. And I hate fencing little kid. Little kid. No. If you fencing a little kid, the mentality of little kid is I'm gonna kick your ass. It doesn't matter how good you are. They are not afraid of you. They want to kick your ass. So the problem is you always scared of the things. What you right now, you're scared of it. The problem is you need to stop letting go. You need to letting go to fear and just says, I'm gonna beat you.
I'm scared I won't be
Yeah, I just don't know where my opponent is.
Then you haven't tried yet.
If I could do this, Mr. Gay, I would be doing I would be like,
You can do this.
They sabotage
you know what?
my
I'm gonna try to do it.
Yeah, there we go. This is the switch of attitude. Thank you.
The way I thought about it was we explained just I can't pull anything out, right?
Pull out one.
You're in.
What are you
What?
doing?
Still connected.
Just leave it out there.
But if you want to go back and check your work, yeah, it's the same thing. Does that make sense?
Okay.
Where
Where-
What do you mean? Where?
Oh, shoot.
Okay.
The problem that they did is I can't for
It's
like
like
a polynomial.
X. Because it keeps it-
Okay, I split it to 3 integrals. I mean, this is I usually don't do this, but it's just this because this is just
That's literally what I was doing.
the 2 that's gonna be in the front. That's gonna be fine. Just move the 2 outside. Now you don't even have to do this, but I will show you. But it's not that bad. What's the integration of x squared? X to the 2 plus 1. Does that make sense?
Yep, over 2 plus 1.
Over 2 plus 1. Good.
Bro, Mr. Yeah, I literally had that written on my paper after you told me to just start.
The problem is you guys are so afraid of starting.
Nah, look at what I did on my paper. That's what I have on my paper. That's what I have on my paper. Period. Oh.
It's not hard.
Let's go, bro. Yes. Okay, wait. I didn't get that. Wait, what part?
Integration 1 is going to be x.
I'm ready to help, bro.
Okay.
You think rid of the x is just equal to 1.
So integration 1 is going to be x.
Yes, but 1 is the antiderivative. If you just get rid of x, it's equal to 1.
So make sure when you do calculus, you want to do algebra first because integration x to the n dx, this is on the numerator. So that does not mean integration of 1 over xn is going to work. Not work. Okay, why is not working? Because integration x to the n. So then you have to follow this full process. So if not full process, but if you have original integral, right? What you're gonna do is you're gonna actually have to rewrite. Why is rewrite important? Because you want to make sure x is on the numerator, and then you're gonna integrate, and then you're gonna simplify. Okay, so simplify. Simplify. Okay, so what I mean is like this. What if I have integration 1 over x cubed dx?
X to -3?
Why?
Because you want to put it in the numerator.
You want to put a numerator, but you have to follow the exponential rule. What is exponential rule? X to the n, negative n equal to 1 over xn, right? How about x 1 over x to the n? That's equal to x to the n, negative n. So then that's going to be integration of x to the -3 dx. Am I losing somebody? This is called rewriting. Why is rewriting important? Because you cannot integrate when the x is on the bottom. You have to integrate when the x is on numerator. Now, can I integrate this? -3 plus 1 over -3 plus 1, right? Plus c. So it'll be x to the -2 over -2 plus c. Now, I have to simplify it too. If I simplify it, it's going to be 1 over -2x squared plus c. If you don't believe me, take a derivative of this, see if it's right.
No, we believe. Yeah, I'm chilling without checking that one.
Yeah.
We have faith. We fit.
Are we okay here?
Yeah.
Can you guys take an integration of this one?
You got this guy.
Well, x to
I
negative
don't
1
have
half.
faith.
Oh wait, we don't do that. Hey, 1/2 over 1/2.
So easy.
I swear, this doing math is about confidence.
Well, split back over to
That's not true. You are one of the best.
Yeah. No, it's just two.
I got square root.
Plus B.
Wait,
Plus
hold on.
one.
The Z.
Oh, I knew that was gonna
Plus
happen.
one right here. So you get x to 1/2 over 1/2, right? Does that follow?
Yeah.
That's literally what I got.
So it would be square root of x over 1/2, right? We change flip it. 2 times the square root of 2.
Yeah.
Yeah.
Using definition radical, m over n equal to n roots of a to the m. And that's use this to convert negative 1/2 dx. I just rewrite it. I haven't taken integral yet. I rewrite it. Now I'm going to take integral. X to the negative 1/2 plus 1 is going to be 1/2. Does that make sense? So if you divide it by 1/2, it's going to keep change flip. So it'll be 2x to the 1/2 plus c, or 2 square root x plus c. Either one is acceptable.
I like it to the 1/2. That makes it easier.
That's fine.
Math.
Mia, do you understand? I changed this to 1/2 power. Do you understand, Mia? I'll move to the top to become negative 1/2 power. And I integrate by plus 1 over plus 1. Negative half plus 1 is going to be half. You look like you're... Okay, so think about it. This part here, I'm going to erase this part. I'm going to say that's x to the 1/2 over 1/2 plus c, right? Now, if you divide it by fractions, so it'll be x to the 1/2 divided by 1/2. That's same thing times 2. Does that make sense?
Monsieur, for the x1, I thought it was n minus 1.
That's for regular power.
Right,
It's
I'm
plus
losing my
1
mind.
for
It's
the
not
n.
right.
Does that make sense, Mia? Are we okay here? Okay. Let's talk about our next one. Will be integration of x plus 1 over square root x dx. Now remember this, before you start, rewrite using algebra. Now, do you remember when we tell you, in order to take a derivative of x plus 1 over square root x, do not use quotient rule. Why?
You just split it.
Good. Same thing about integral as well. Because your life is going to be a lot easier because there's no actual rule for quotient rule for integrations.
I got this. We go. Go.
Splitting is one of the most important strategy in calculus. One of the most important. Because it can take you from a hard problem to a simple problem.
Does that make sense? Yeah. So what would you do here? What the heck do you do? So integral that times the root of you see what I'm saying? I believe in that. Oh. Ooh. Oh. Oh, we're an idiot.
You just told me splitting. What did you do, Deborah?
You both are. So that one is
piano and put it a little differently then. But I can't understand. Plus C.
Oh.
Yes, there you go.
That makes sense. Let's see.
So it'll be x to the, what's 1/2 plus 1?
3.
This is 2 over 3. Does that make sense? Because dividing by fraction just automatically change to the front. Is that okay? Plus x to the 1/2, 2 plus c. Why is 1/2? It's going to be this. So I'm not going to change this question too much. I'm going to change it slightly. Now, most of the people is going to make mistake is an algebra mistake rather than calculus mistake. Because calculus is actually simple. It's plus 1 over n plus 1. And you say, okay, well, what does that mean I'm going to change? What if I change this? Same thing, but do this.
But I did this all by myself.
You should be proud. But don't kill a kitten here, or don't kill a puppy here.
I don't understand that one.
I eat dogs, but doesn't mean I want you to kill them. No, I don't eat dogs. I'm vegetarian.
No.
I'm vegetarian. Jesus. I've never eaten meat in my entire life.
Your entire life.
Yes.
Oh, you're
You like it. You just have no idea.
I don't like it.
No.
Just don't.
You know, something that's fine.
Is it like a health thing or like a religion thing?
I was grew up in a monastery,
What do you guys
Oh,
actually?
a Buddhist temple. Yes.
You were born in a Buddhist temple?
He grew up.
That's so cool, actually.
That's really cool. What was it?
In Taiwan.
What? That's so cool.
All right, finish your problem. Shh. Finish your problem.
You grew up in a Buddhist monastery in Taiwan?
I want to be Mr. Yang.
The whole backstory.
I don't know if you'd want to be. What do you guys think?
Wait. Yo, so what you do is you expand, then you split.
That's what I was
I
thinking.
Okay.
But don't expand it wrong.
Bro, I got my partner. I gotta redo this.
No, I don't get it.
Oh, okay.
I get it. Shut up, buddy. What the? I'm so done with y'all.
It's like a tire bomb.
Yeah.
Expand it and then split it.
Yeah,
expand it.
I'm sorry?
What time we get off here?
9,
Okay.
I'm struggling, bro. We got 1 minute.
Wow.
Did you guys expand it correctly?
Yeah.
Yeah, bro. Trust like that.
Good damn.
Why? Because x plus 1 squared, that's equal to x plus 1 times x plus 1. You need a FOIL.
Integration. Let's go.
Oh my god, wait, did you get this? So, thus far.
Hey, bro. I'm still working. Yeah.
Any questions so far?
No.
I'm chilling.
So x to the 5 over 2, 2 over 5, plus 2x to the 3 over 2, 2 over 3, right? Plus, minus x
I literally had that, so.
to the 1/2. This one is, no, not minus, this one is plus. 2, right? So it'll be 2 over 5, x to the 5 over 2, plus
But that is gonna last.
4 over 3, x to the 3 over 2, plus 2x to the 1/2 plus c.
Yeah, but then I can't raise properly, and then it upsets me.
Oh, hey, 6. That's early.
If I didn't make mistakes, then I wouldn't need to race there. You know what I mean? Bye, Mr.